Our objective for today, I can solve a system of linear inequalities by graphing. Let's read together. 1, 2, 3. I can solve a system of linear inequalities by graphing. So if you notice, today's main theme is going to be systems of linear inequalities. What are we doing? We're going to be solving by graphing. So the main thing that we're going to be doing is graphing to find a solution. So what are systems of linear inequalities? You need your Fourier model. Here we go. System of linear inequalities are a set of two or more linear inequalities that have the same variables. System of linear inequalities is a set of two or more linear inequalities that have the same variable. Example, y is less than or equal to 3x plus 1 and negative 4x plus 2y greater than 6. That's one example. Another example is negative y less than x minus 5 and y greater than or equal to 2x plus 1. All right? Once again, definition is set of two or more linear inequalities that have the same variable. Let me show you a non-example. Non-example is y equals 1/2 x minus 2 and 4x plus 2y equals 12. This is a non-example. Let me show you another one. Y greater than negative 2 plus 1/2 x. So, copy those, please. So, here goes the concept. Concept for today is systems of linear inequalities. Pens down, eyes up here. According to the definition says that it's a set of two or more linear inequalities that have the same variable. Let me see an example. Is this a set of two or more? Yes, linear inequalities with the same variables, okay? How about this one? Set of two or more, yes, of linear inequalities with the same variables. With that said, think about these. Don't say it out loud. Why is this not an example? And why is this not an example? This is not for a purpose, and this is not for a purpose. All right, talk it over with your neighbor. Why are these non-examples? So that's right. So the most important thing to remember a system of linear inequalities is that they need to be what? Two or more linear inequalities, and they have to have the same variables. Two or more linear inequalities, and they have to have the same variables. Two or more linear inequalities, and they have to have the same variables. Excuse me. Now, since we're graphing today, tell your neighbor step 1. Solve for y. Copy these down, please. Step 1, solve for y. Step 2, graph the inequalities. Step 3, check a point and shade the solution set. Step 4, state the domain and range for the solution set. Copy that. So, 4 basic steps. Solve for y. We already know how to do that. Graph the inequalities. We know how to do that. Check a point and shade the solution set. We know how to do that. State the domain and range of solution set. So you're saying, so what's so different today? Well, let's find out. However, before we go to graphing, I'm going to give you some more practice on checking a point, because now it's a system of linear inequalities. Even though it sounds the same, just differs just a little bit by the way it looks. Here we go. Copy this example down. Example 1a says, tell whether the ordered pair is a solution of the given system. Tell whether the ordered pair is a solution of the given system. The point given is -1, -3, and the system is y less than or equal to -3x plus 1 and y less than 2x plus 2. Example 1a. And by the way, guys, notice this writing right here where it says tell whether the ordered pair is a solution. Basically, what that means is for us to check. But it's just wording. You know what I'm saying? So, do we know how to check? Yes. We've done this before with systems of equations. So all we do now, we rewrite these side by side. I'm going to write this one here, y less than or equal to negative 3x plus 1. And I'm going to write the other one over here, y less than 2x plus 2. And how do we check? We substitute the values into the inequality, right? This is x, this is y. Let's do this one together. So what is x? Negative 1. And what is y? Negative 3. And I bring everything else down, the less than or equal to, the minus 3 or negative 3, and plus 1. Let's continue. This is negative 3 less than or equal to. What is negative 3 times negative 1? 3 plus 1. So therefore negative 3. Is negative 3 less than or equal to 4? Yes, that's true. However, in order for it to be a solution to the system, it has to be true for both inequalities. Remember that? Does it ring a bell? Yeah, it's kind of like equations. It needed to be true for both. So let's check this one. Once again, what is x? Negative 1. And what is y? Negative 3. Bring everything else down. Less than 2 plus 2. Negative 3 less than, what is 2 times negative 1? That's negative 2 plus 2. Negative 3 is less than 0. Is that true? Yes, that's true. Therefore, you need to write negative 1, 3, negative 1, negative 3 is a solution to the system. 10Q. You're like, that's it? That's it. That's for checking. And once again, what needs to be true in order for it to be a solution? That it has to be true for both. Tell your neighbor again, what? Okay. So with that said, let's see if you can do the next one by yourself. Here you go. Example 1B. 1B. Copy this. We're just checking right now. Example 1B. Copy this down, please. Example 1B. Yes, right now we're just checking. Example 1B. Tell whether the ordered pair is a solution of the given system. You don't need to rewrite the instructions. You already have them. The ordered pair that they give us is negative 1, 5. And the system is y less than negative 2x minus 1. And y greater than or equal to x plus 3. Okay, copy that and check it, please. Okay, here we go. So the first thing you did, you rewrote these, and you're gonna check the first inequality by substituting negative 1 for x and 5 for y. So you did that, and what did you find out? That it was false. Is that true? Yeah. And at that point, you just stop, and you just write negative 1, 5 is not a solution to the system. Why didn't we have to do the other one? Because what did we say earlier? It has to be true for both. But as soon as you find out that one of them is not true, but what did we do? We went ahead and did the other one, right? So therefore, from now on, remember, whenever you encounter the very first one and it's false, you can stop there and just write your statement. Negative 1, 5 is not a solution to the system. No. Okay, and do this next one by yourself. Example 1C, 1C, last one of these. Copy this one. Example 1C, 1C. Same instructions, and the ordered pair is 0, 1. The system is y less than negative 3x plus 2, y greater than or equal to x minus 1. And I want to see if you actually see what I see. Okay. So, you checked the first one. You found out that it's true. So we go to the next one. Well, look at it. Here it is. We go to the next one, and we find out that it's also true. So therefore, 0, 1 is a solution to the system. Hands if you got that. Good. So now, we're done with checking. We know how to check. Now let's go to graphing. Get your graph paper in front of you, please. And at this point, if you have your colored pens, get those ready, please. You're going to need them. Okay, here we go. I only have one. Here we go. On the big graph paper and the top left, copy this one now, please. Be nice. Here we go. And you made some by computation. All right, here we go. Example 2A. In your graph paper, the big coordinate plane at the top left. Copy this down. It says, yes, graph the system of linear inequalities, then give two ordered pairs that are solutions and two that are not solutions. Yes, write this down. The system is negative 3x plus 2y greater than or equal to 2 and y less than 4x plus 3. Copy that, please. All right, so let's graph this. What is our first step for graphing? Okay, so let's solve for y. Here we go. Oh, sorry. Give me a second. Something's happening here. Okay, here we go. Solve for y. I'm going to rewrite this first one down here. Negative 3x plus 2y greater than or equal to 2. So we need to solve for y, which means we need to get rid of this x. So by adding 3x to each side, we got that done. We're left with 2y greater than or equal to 3x plus 2. What's my last step? Divide by 2, divide by 2. Y is greater than or equal to 3 over 2x plus 1. Okay. If you notice, I started solving this one for y with blue. So for those of you that have pens, follow along. Now we're going to graph it in blue. Here he goes. What do I need of information here to graph? My y-intercept, which is 1. There it is. And the second thing that we need to plot points is our slope. What is our slope? 2 to the right. So here we go. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Now we need to graph our line, but before we do, we want to make sure it's the correct one. Does it have an equal sign? Yes, so what kind of line are we going to sketch? A solid line, and I'm going to do that in blue. There it is. Make sure you extend it as much as you can. All right. Next, we're still not done. Let's shade our section. Here we go. What information do I need from here in order to shade? Here we go. I need the y greater than or equal to 1. Okay? So let's see. Y is greater than or equal to 1. So let's look for the axis, y-axis. Here it is. And it says y is greater than or equal to 1. What numbers are greater than or equal to 1? Everything up. So that means we're going to shade up. Those of you that don't have colored pens, just use your pencil and just sketch lines like this so you can shade that section. Above that line that we just graphed. All right, here we go. Next. We're done with that one. Let's go to the next. Is this one already solved for y? Yes. Therefore, what information do I need to graph? Y-intercept, which is 3. So let's plot our point at 3. There it is. And what else do we need? Our slope. So what is my slope? 4 up, 1 to the right. So from here we go 1, 2, 3, 4, and 1 to the right. 1, 2, 3, 4, and 1 to the right. And some of you have a larger graph than mine, so you can go one extra step. Before I graph my line, though, I look at the inequality symbol. What kind of line am I graphing? Dashed, a dashed line. Yeah, because it doesn't have an equal sign. Is that correct? Yeah. All right, so then let's graph a dashed line. Make sure you extend it as much as you can. There it is. Okay. Let's shade it. Let's see. What information do I need from here in order to shade our region? We need the Y, the left, and 3. So now, let's go over here. Here's 3. What numbers are less than 3? 2, 1, everything down here. So now check this out. For those of you that have pencil, this is what I want you to do. Instead of drawing lines down like this, I want you to draw them across. But everything on the right side of that line we just drew. Everybody see that? If you have a colored pen, do the same thing as I'm doing. Okay, here we go. So then this, and do it all the way through the top like so. Do the same thing as I'm doing. Okay? Everybody there? So let's see. It said, graph the system of linear inequalities. We already did. Give 2 order pairs that are solutions. Now check this out. Pens down, eyes up here. Focus, please. Now this is what I wanted to show you, especially with color. Now we can actually see a little bit more clear where the solution set is at. The solution set, pay attention please. Let me go back to the previous problem. What did we find out with these? That in order for this to check to see if there was a solution, what needs to happen? It has to be true for both. That means if we go to our graph, think about it. It's where both are graphed. So does everybody see the intersecting part where both of them? Check this out. If you don't see it, let me highlight it. Everybody look up. Notice that the red and the blue intersect in this section. This section, all the way, and it continues going that way. All that is called the solution set. So write it in there, solution set. In black or with a pencil. It's up to you. So, what does that mean? What that means is that if I pick any of these points in here, it's going to make both inequalities true. Everybody with me? All right. So, if it says, give 2 order pairs that are solutions. So that means I'm going to get 2 points from in here. I'll give the first one. Here it goes. I'm going to take the first point that is a solution. And I'm going to say it's 2, 6. You see how it's in there in that solution set? So this is 1 order pair, 2, 6. I want you to select the other one by yourself. Select another order pair. Go. Yes. Yes. So with that said, let's see. What's your order pair, Emily? Emily says 2, 7, and everybody look up. Is 2, 7 part of that solution set? Yes, 2, 7. Let's see, someone else. Go ahead, Marco. 8, 16, which is way up here. Is that part of the solution set? Yes, because it continues going. Maddie, what other? What is it? 112, let's see. Is this part of the solution set? No. Look at it. 19, let's see. 19, nope. It's 3, 6. Yes, that is part. Once again, what did we just find out? That our solutions have to come from this intersecting area. Everybody with me? Yes. All right, so Samuel Perdomo, can you give me a non-example? 1-1. Let's see. Look at 1-1 is right here. Is 1-1 part of that solution set? No. So this is not a solution. Okay. However, let me ask you this. Everybody look up. This is not a solution. We already agree with that, right? However, this will make one of the inequalities true. Which inequality will this one make true? The second one. Does everybody see that? Because this shading belongs to the second one. Therefore, everybody look up. Look at the one that Maddie gave us over here. This one right here. It's not a solution, but which one will it make it true? The blue one or the first one. Does everybody understand that? So with that same thought, think about this. Don't say it out loud. Pay attention, please. What if I picked this one? Don't say it out loud. Okay? Think about it. What's going to happen if I was to substitute that into these? Think about it. Talk it over with your neighbors. What's going to happen with that? So yes, so what did we find out? That this point will not make either one true. Are we there? Then it would be true for both. It would be in here. Okay, let's do another one. Let's see if you can do this one by yourself. Turn your paper over, your graph paper over. Copy this one. On the small one in the back. Small one in the back. Example 2B. Copy this one down, please. You don't have to copy the instructions anymore. Just copy the system. Y is less than or equal to 3x minus 4, and y is greater than negative x plus 7. See if you can graph the solution set for that one. From there, you're going to plot two order pairs that are solutions and two that are not. Go. No. Go. So I'm going to graph the first inequality. Since it's already solved for y, I circle my y-intercept. That's negative 4. And I'm graphing this in red. The slope is 3. That means 3 steps up, 1 to the right. So I go 3 up, 1 to the right, 3 up, 1 to the right, 3 up, 1 to the right, 3 up, 1 to the right. And by looking at the inequality system, it's a solid line. So I'm going to graph that in red, solid line. There it is. And what information do I need to graph my shaded area? I need the y, the less than or equal to, and the negative 4. Hands if you did up to right there. Okay, so now I'm going to use this to graph my shaded region. Y is less than negative 4. What's less than negative 4? Negative 5, negative 6, negative 7, everything down. So I'm going to shade down for this one. No, you have to go down, not up. Okay, there it is. Hands if you got that far so far. Okay, good. Next. The next one. I'm going to do this in blue. I start at 7, which is right there. And my slope is 1 down and 1 to the right. That's why it's a negative slope right here. Okay, it's never to the left, always to the right. Here it goes. 1 down, 1 to the right, 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 One down, one to the right. All right, so now, by looking at the inequality symbol, it's a dotted line. Here it goes. I'm going to graph that in blue. There it is. And then what information do I need to shade? I need y greater than what? 7. What numbers are greater than 7? Everything up here. So that means I'm going to shade everything above this line, but I'm going to go across this way. Just so I can see the intersecting region. So therefore, who wrote, everybody look up, who wrote solution set in this area right here?
I did.
Hands if you got that. Okay. From there, they're asking you to select 2 ordered pairs from the solution set. I'm going to select, let's see, 7, 1. Is that a part of the solution set?
Yes.
7, 1. And then another one would be 5, 5, 4. Is that part of the solution set? 5, 4. Okay. And then it says to select 2 that are not part of the solution. Emily, which one was yours not part of the solution? 3, negative 1. That's true. That's not part of the solution. How about another one, Elsie? Yes. 1, 2. That totally is not. That doesn't belong to any of them. Good. One more, Ryan. That is not part of the solution. Okay, Marco. That's not. $14, $15, that is part of the solution. What other? Negative 14 and what? Negative 14, 15, which is way up here, that's not part of the solution. I'll stop right there. Yeah, question. Let's see. 3, 4. 3, 4 is right here. Good question. Isn't this point on the dotted line? Is that part of the solution? No. If it's solid, yes. On the solid, yes. But it has to be where both of them meet. So, homework for tonight is found on pages what?
334. 127 odds.
1 through 27 odds. Page 374. Turn in your homework on your way out. If I don't see you here for tutoring, I'll see you tomorrow. Yes, enjoy your homework. See you guys tomorrow.